This video is to help you with the learning target. I can use two variables to solve a distance problem. A boat traveled 210 miles downstream and back. The trip downstream took 10 hours. The return trip took 70 hours. Can you draw a picture? Can you visualize the situation? What is the speed of the boat? What is the rate of the current? Once again, we have a linear function model. Rate times time equals distance. Very similar to our mixture function model, which was volume of a mixture times concentration equals volume of substance. And also similar to our work linear function model, hours worked times rate of work equals work completed. In this case, we have rate times time equals distance. And if you think about the question, we had the boat rate and we had the current rate. If we're going downstream, we need to be sure to understand that we're going to be adding the current to the boat. And if we're going upstream, we're going to be subtracting the current from the boat. If you anticipated it and are correct, we're going to use a table again. We'll use the table. We're at the very top of the table. We're going to have our model, rate times time equals distance. The rate for downstream is the boat rate plus the water current rate. The rate upstream is the boat rate minus the water current rate. We multiply across in order to find the distance. And we need to give some thought here that the distance is 210 miles. So we're going to go across on our rows to get the first equation and across on our second row to get our second equation. We get the equations using the very last column. So we have 10b plus 10c equals 210 and 70 minus 70c equals 210. We're going to go ahead and use the elimination method. In red, using the elimination method with the equations that I started with, we would have to get our 10b plus our 10c equal to 210 and create opposites in the place of the equations with the c variable, since we already had a plus and a minus sign. Solving for b in this case, we find that b equals 12. So 12 miles per hour would be the rate of the boat. If you were a thinker, you may realize that you can go ahead and simplify your two equations, in which case now you just have a b plus c and a b minus c, and we could solve this for b after eliminating the c's and also find our 12 miles per hour. This was convenient since we were able to divide the first equation by 10 and the second equation by 7. The boat is traveling 12 miles per hour. Now we need to find the water current rate. So if b plus c equals 21, then that would tell us that c must equal 9. The water current is a rate of 9 miles per hour, and the boat rate was 12 miles per hour. Hope you found this helpful, and bring questions to class, and we'll practice more distance problems for this learning target. Thanks for watching, and have a good evening.